Hi children, under Form 7 Chemistry, today we will discuss topic 12, Entropy and Energetics. You can refer textbook page number 32 to 53. Objectives. Under Entropy and Energetics lesson, there are 11 objectives. Here basically we can learn what is an entropy, how to measure this entropy, and we can understand entropy of a substance increases with temperature or increases with state changes like solid to liquid to gases. And we can understand how these entropy changes are occurring. In this lesson, we can learn entropy equation. Delta S total equal to delta S system plus delta S surrounding. We can do the calculations using this entropy equation, as well as we can understand the feasibility of the reaction. And we can learn the concept of thermodynamic stability and kinetic stability. In this lesson, first we will discuss what is an exothermic reaction, what is an endothermic reaction. The chemical reactions give out heat energy as they take place. So the products have less energy, or we can say products are more stable than the reactants. This type of chemical reactions are exothermic reactions. Some of the chemical reactions taken in heat energy. So the products have higher energy, or we can say the products are less stable than the reactants. These are known as endothermic reactions. But in our practical knowledge, we know most of these endothermic reactions also feasible, not only exothermic reactions. In this lesson, under entropy, we can learn how they are feasible. Now we will learn entropy. It is an important factor for chemical reactions. Essentially, materials go to their most likely condition, or we can say the most probable situation, that is where there is the maximum freedom. So we can say the greater the freedom molecules have, the greater the entropy. So the molecules become more randomly distributed, their entropy also increasing. The symbol used for entropy is capital S. Now we will learn entropy of substances according to their physical state. If there is solid state, there is the lower entropy than other states. In liquids, the molecules have greater freedom of movement than solids. So liquids have higher entropies than solids. This means for the dissolved substances also will have higher entropies than solids. Then if we consider gaseous molecules, they have much greater freedom of movement. Because of that, they have comparatively high entropy values. Now look at this diagram. You can see solids have very lower or the least entropy. Then if you consider liquid, they have higher entropy than solids. If you consider gases, they have more freedom, more disorder. Because of that, they have higher entropy values than solids and liquids. Now we will learn entropy equation. When a chemical reaction takes place, new substances are formed. The products of a reaction will have different entropy values to the reactants. So the entropy of the system changes. The change in entropy can be found using the following equation. Delta S system equals to delta S products minus delta S reactants. Or we can say change in entropy of the system equals to change in entropy of products minus change in entropy of reactants. For spontaneous change to take place, the entropy should be increased. Changes that incur an increase in entropy include formation of gas molecules, dissolving of a solid, decomposition of a substance, gases becoming more randomly distributed, or we can say diffusion. Now consider this example. When magnesium metal burns, the magnesium atoms combine with oxygen and form magnesium oxide ionic lattice. In this change, a gas is converted to a solid. So the entropy in this change seems to decrease and break our rule about spontaneous change. So here entropy change is minus 221.5 joule per Kelvin per mole. The unit of entropy is joule per Kelvin per mole. However, as the reaction takes place, energy is given out. Given out means it is an exothermic reaction. So the surrounding molecules gain energy, so gain entropy occurs. When considering entropy in changes, it is necessary to consider what happens to the surroundings as well. So because of that, we can say delta is total. It means change in entropy total equals to change in entropy system, delta S system, plus change in entropy of surrounding, delta S surrounding. So we can say easily delta S total equal delta S system plus delta S surrounding. Any entropy increase in the surroundings comes from the energy which the system gives out. An increase in entropy depends upon the proportional increase in energy of particles in the surroundings. For example, the surroundings gain 20 kJ of energy. The proportional increase is greater if the surroundings originally have low energy. Actually, temperature is a measure of the energy of molecules. So the change in entropy in the surrounding is delta surrounding equals to minus delta H over T. So now we discussed three equations. Delta S system equals delta S products minus delta S reactants. Delta S surrounding equals minus delta H over T. Delta S total equals delta S system plus delta S surrounding. In here, we will discuss the feasibility of the reaction. We can say if delta S total is positive, the reaction is feasible. We can calculate the feasibility of the reaction using delta S total equal delta S system plus delta S surrounding, or you can say delta S total equal delta S system plus negative delta H over T. Here delta H over T means delta S surrounding. Here I am giving 4 scenarios for enthalpy and entropy changes, whether the reaction is spontaneous or non-spontaneous. Now we will discuss first scenario. Delta H is more than 0. It means it is an endothermic reaction. Delta is also more than 0. It means increase in entropy. Here the process or any reaction is spontaneous at high temperatures. If delta H is lower than 0, it means it is an exothermic reaction. And delta S also higher than 0. It means entropy also increasing. Process is spontaneous at any temperature. Third scenario. Delta H more than 0. It means it is an endothermic reaction. Delta S lower than 0. It means entropy is decreasing. Process is non-spontaneous at any temperature. Maybe higher or maybe lower temperature, the process is non-spontaneous. It is not feasible. If delta H is lower than 0, as well as delta S also lower than 0, so the process is spontaneous only at lower temperatures. Now you know there are the 4 scenarios for enthalpy and entropy changes, and you can decide according to that whether the reaction is feasible or not. Here I am discussing simple entropy calculation. For the example, burning magnesium. Here I am giving delta H value. It means enthalpy value minus 1204 kilojoule per mole at 298 Kelvin. And I am giving delta S system. Delta S system equal minus 221.1 joule per Kelvin per mole. Now we have to find out delta S total. How we can find out delta S total? As we know, delta S total equal delta S system plus delta S surrounding. Already they are giving delta S system. Then how can we find delta S surrounding? As we know, delta S surrounding equal minus delta H over T. Here they are giving delta H value and they are giving temperature. So substituting these two values, we can find out delta S surrounding. Now we can substitute delta S system value, delta S surrounding value, and you can find out delta S total. If the delta S total value, or we can say overall entropy change, is positive, the reaction is feasible. Solutions. When an ionic substance is placed in water, the water molecules being highly polar are attracted to the ions. The oxygen in the water molecule carries a partial negative charge and is attracted to cations. The hydrogen in the water molecule carries a partial positive charge and is attracted to anions. The process of water molecules linking to ions, cations or anions, is called hydration of ions. The water molecules are vibrating, so as they bond to the ions, they shake the ions free from the lattice. Thermodynamic explanation for hydration of ions. In previous slide, we learned what is hydration of ions. So some ionic compounds do not dissolve in water because the electrostatic attraction between the ions is too great for the water molecules to overcome. Therefore, there are two key energy processes taking place as an ionic substance dissolves. The first one, the lattice has to be broken apart. This is an endothermic process. Next process, new bonds form from the water molecules and the ions and exothermic process take place. The energy change that takes place when a solution dissolves is a balance of these two energy changes. Now we will learn the definitions of lattice enthalpy, enthalpy of hydration and enthalpy of solution. First we will learn what is lattice enthalpy. The heat energy given out when 1 mole of a crystal lattice is formed from separate gaseous ions at an infinite distance apart under standard conditions. Here, M plus gas molecules react with X minus gas molecules and form MX ionic solid. Then we will talk what is an enthalpy of hydration. The heat energy given out when 1 mole of gaseous ions dissolved in an excess of water to form an infinitely dilute solution under standard conditions. Here if we consider M plus gaseous cations, it is react with aqueous solution and form M plus aqueous. If it is X minus gaseous ions, they are reacting with aqueous solution and form X minus aqueous solution. Enthalpy of solution. The solution enthalpy is a measure of the amount of heat energy change when 1 mole of substance is dissolved in excess water. It means M plus cations in gaseous molecules plus X minus gaseous molecules react with aqueous water and form M plus cations in aqueous and X minus anions in aqueous. Now we learned lattice enthalpy, enthalpy of hydration and enthalpy of solution. Now we will learn more about lattice enthalpy. It means what are the factors the lattice enthalpy is increasing. Here the lattice enthalpy is a measure of the strength of an ionic lattice. Here I am giving some values of lattice enthalpy. If you consider sodium fluoride, lattice enthalpy minus 923 kilojoule per mole. If it is calcium oxide, lattice energy minus 3513 kilojoule per mole. Now we will learn why there is any difference. Now we will discuss factors affecting lattice enthalpy. When the size of the anion increases, lattice energy is decreasing, as well as the size of cation is increasing, the lattice enthalpy is decreasing. This is because the sum of radii increases, the electrostatic attraction decreases. Therefore, lattice enthalpy decreases, a consequence. Then we will discuss the charge. Higher the charge on either or both of the ions, the greater the lattice enthalpy. This is because charge on the ion increases, the electrostatic attraction also increases. So, lattice energy becomes greater. Now we will discuss hydration enthalpy. The hydration enthalpy is a measure of the attraction between an ion and water molecules. Here I am giving some values of hydration enthalpy. So we can get the idea, the factors affecting hydration enthalpy. You can see when the size of the cation increases, the value of the hydration enthalpy drops. If you consider lithium plus, hydration enthalpy is minus 499 kilojoule per mole. But if you consider potassium plus, the hydration enthalpy minus 305. So it means the size of cation increases, the value of the hydration enthalpy is decreasing. The reason, the distance between the center of ionic charge and the water molecule increases, the electrostatic attraction decreases. Therefore, hydration enthalpy decreases. As well as increasing size of an ion causes a decrease in the hydration enthalpy. The reason, the higher the charge on the ion, the greater the hydration enthalpy. As the charge on the ion increases, the electrostatic attraction also increases. Therefore, the hydration enthalpy becomes greater. According to the knowledge we know, I can give an equation. Delta H solution equal minus delta H lattice plus delta H hydration. Now we will talk enthalpy of solution. The enthalpy of solution is related to the lattice and hydration enthalpies as follows. Now you can refer this energy diagram. You can find out delta H solution by using that equation, delta H solution equal minus delta H lattice plus delta H hydration. You can just substitute the values using enthalpy diagram or enthalpy graph they have given. So here delta H solution of sodium chloride equals to minus 776. So it is minus plus. Then plus, you can find out delta H hydration value minus 390 plus minus 381. So the total answer is equal to delta H solution sodium chloride plus 5 kilojoule per mole. But when we consider this answer delta H value, it is an endothermic reaction. Then how this reaction occurs spontaneously? So we have to get the look at entropy changes involved in this reaction. As we know, delta S total equal delta S system plus delta S surrounding. Due to this is an endothermic reaction, delta S surrounding is negative. But delta S system value has a high positive value. Because of that, the process of dissolving means that a highly ordered ionic lattice becomes a much less ordered solution of ions. Due to this reason, the reaction is feasible. Here I am giving the enthalpy diagram for the reaction, the dissolving of ammonium chloride. You can see delta H lattice, delta H hydration, and they are giving delta H solution value. Using these values, we can find out dissolving of ammonium chloride, whether this reaction is feasible or not. Here, the values of system entropy and enthalpy of solution are shown below. Delta system equals to plus 278.5 joule per Kelvin per mole. Delta H solution value plus 16 kilojoule per mole. If they are giving delta H solution value, and as we know the reaction occurred at room temperature, we can find out delta S surrounding, because delta S surrounding equals to minus delta H over T. You can substitute the values and you can get the answer. Delta S surrounding equals to minus 53.7 joules per Kelvin per mole. Then you can find out delta S total. You know delta S system and you already calculated delta S surrounding. Addition of delta S system and delta S surrounding, you can get the answer delta S total. Here the delta S total value plus 224.8 joules per Kelvin per mole. Then we can predict ammonium chloride will be soluble or the reaction is feasible. Now we will discuss module questions and answers. Question number 1. When barium nitrate is heated, it decomposes as follows. Barium nitrate decomposes to barium oxide solid, nitrogen dioxide gas and oxygen gas. Here they are giving delta H value plus 505 kilojoule per mole, and they are giving entropy values for each of the substance. First part. Explain why entropy of nitrogen dioxide gas is greater than entropy of barium oxide. Simple answer. Nitrogen dioxide is a gas, but barium oxide is a solid. Therefore, nitrogen dioxide gas has a more disorder. Next one, entropy of barium nitrate solid is greater than entropy of barium oxide solid, because barium nitrate has a more complicated structure than barium oxide. Second part, calculate the entropy change of the system. For this reaction, include a sign and units in your answer. How can we find delta S system? Delta S system equals to delta S products minus delta S reactants. So here you can substitute the values of delta S products and delta S reactants, and you can get the answer plus 439.1 joules per mole per Kelvin. Part B. Calculate the entropy change of the surrounding for the reaction at 298 Kelvin. How to find delta S surrounding? Delta S surrounding equal minus delta H over T. You can just substitute the values and you can get the answer minus 1700 joule per mole per Kelvin. Part C. Calculate delta S total and explain the significance of the sign for this value. You can find out delta S total equal Delta S system plus delta S surrounding. You can just substitute the values you calculated in part 2 and part B. And you can get the answer minus 1260 joule per mole per Kelvin. Here, delta S total is a minus value. So we can say the reaction is not spontaneous or does not go at room temperature at 298 Kelvin. Assignment: complete all checkpoint questions and all chapter and questions under topic 12, entropy and energetics. You can refer these YouTube links and PDF and you can get a better idea. Thank you for listening to my presentation.